Hello everyone, welcome to my channel Worldwide Tutoring. Today in this video we will see how to draw Lewis structure using this formula S equals N minus A, where A is number of electrons available in the valency shell, N equals all atoms need 8 electrons in the valency shell except hydrogen. Hydrogen needs only 2 electrons in the first shell to complete. But all other atoms, they should have 8 electrons to become stable or to complete the octet. Okay, for each atom we write 8 electrons. Only for hydrogen we write 2 electrons. S means number of electrons shared. Okay, now we'll write the formula for NO3, nitrate ion. Number of electrons available in the valency shell. There is 1 nitrogen, 3 oxygens. And there is 1 negative charge, so we write 1 electron. We add 1 more electrons. In the valency shell of nitrogen, there are 5 electrons. Each oxygen, there are 6 electrons. So 3 oxygen means 3 times 6. Plus 1 electron, this one added because there is 1 negative charge. So total comes to 24 electrons. So these are available in the valency shell of 1 nitrogen and 3 oxygens. Okay, now N is needed. All atoms should have 8. So nitrogen, if they are 8, it's stable. And each oxygen should have 8. So 3 times 8 plus 8, it comes to 32 electrons. If there were 32 electrons, then all these atoms will be stable with 8 electrons. But they have only 24 electrons available, so they share. So S is equal to N minus A. So N is number of electrons needed 32, available are 24. I can write here formula S is equal to N minus A. So needed they are 32, available are 24. So 32 minus 24, they are 8. So 8 electrons are shared. Number of bonds, when 2 electrons share, we draw 1 bond. Okay, so each bond means there are 2 electrons are shared. So how many bonds will be forming when 8 electrons are shared? 8 divided by 2. So 4 bonds. So in this molecule, there are 4 bonds. Okay, number of unshared electron which are not used in bonding. So number of unshared electron formula is A minus S. Number of unshared electron, A minus S, available are 24. We can see here available 24 and shared are 8. So 24 minus 8, 16. So these two information we need to draw the structure. How many bonds, how many unshared electron. Okay, nitrogen less electronegative, we draw in the middle and 3 oxygens on 3 corners. And there are 4 bonds, so somewhere we have to place double bond and single bond here and single bond here. Where there are double bonds, there should be 4 electrons. See 1, 2, 3, 4, 5, 6, 7, 8. So this oxygen is having 8. Similarly, this oxygen having 6 and 7, 8. This oxygen also having 6 unshared electron and 2 in the bonding, so 8. So like this, all these 4 atoms are stable. And there's 1 negative charge, we draw 1 negative charge on this. And this is a resonating structure. Double bond can form on this oxygen. So we draw double bond here. When there is double bond, there are 4 electrons. And when there are single bond, there are 6 electrons. Similarly, we place double bond on the third oxygen and 2 other single. So single bond, there are 6 electrons, and total here there are 4. So like this, all the 3 resonating structures we draw. Okay. The next question, we will take one more example, carbonate ion. So CO3, 2 negative is carbonate ion. Formula is S is equal to N minus A. So how many electrons are available in the valency shell? 1 carbon and 3 oxygens. Carbon, there are 4 valence electrons. Each oxygen, there are 6. So 3 oxygen means 3 times 6, 18. And there are 2 negative charges here. So we add 2 negative charge. So altogether it comes to 24 electrons available in the valency shell. Needed means each atom should have 8. So oxygen, if they are 8, is stable. and each oxygen 8 is stable. So there are total 4 atoms, 3 oxygen atom and 1 carbon atom. Total there are 4 atoms. So 4 times 8, 32. So there are 32 electrons, then all the 4 atoms will be stable, but they have only 24 electrons. So they share. So S is equal to N minus A. So needed how many? 32, but they have only 24. So 32 minus 24, 8 electrons are shared. When 8 electrons are shared, how many bonds will be forming? We have to divide by 2 because each bond, there are 2 electrons are shared. So number of bonds will be 8 divided by 2 equals to 4 bonds. To find number of unshared electron, formula is A minus S. Number of unshared electron available minus shared. So available are 24, shared are 8. So 24 minus 8, 16 electrons are unshared electron. So now we know in this molecule there are 4 bonds and 16 unshared electrons. So write carbon here and 3 oxygens, and one of the oxygen will be having double bond because there are 4 bonds. So where double bond, there are 4 electrons, and where single bond, there are 6 electrons. So count and see, there are 16 electrons. So 6 here, 6, 12, 13, 14, 15, 16. So 16 unshared electron, and this whole molecule contains 2 negative charge. This is also resonating structure because we can draw double bond on the next oxygen. So if you draw double bond here, then this oxygen will be having single bond. When there is single bond, we draw 6 electrons, and where there is a double bond, there are only 4 because 4 plus 4, 8. And it contains 2 negative charge. And the third resonating structure, now we put double bond on the third oxygen where there are 4 electron, unshared electron, and other 2 oxygens having single bond, and they have 6 unshared electron and 2 negative charge on the whole molecule. So like this we can draw for carbonate ion. Next, one more example take for hydronium ion, H3O plus. So how many electrons are available? H3O, there are 3 hydrogen and 1 oxygen. 3 hydrogen, 1 oxygen. Each hydrogen in the valence shell, there is 1 electron, and oxygen there are 6. So 6 plus 3, 9. Because there is 1 positive charge, we have to minus 1 electron. When there is a positive charge, we have to subtract. So 1 electron is minus subtracted. So we get 8 electrons are available. Needed, hydrogen can have only 2 electrons in the first shell. So 3 times 2 becomes 6. If there are 6 electrons, all the 3 hydrogens will be stable, and oxygen should have 8 to complete to have like octet structure, to have 8 electron in the valence shell. So 8 electron oxygen will be stable, and each hydrogen, if they are having 2 electrons, then 3 hydrogens will be stable. So total how many? 14 electrons if they were there, then all the 3 atoms will be stable. But they have only 8 electrons available. So they share. So S is equal to N minus A. So needed how many? 14. Shared are, available are 8. So 14 minus 8 is 6. The 6 electrons are shared. How many bonds? Number of bonds will be 6 divided by 2 is equal to 3 bonds. So in this formula, there are 3 bonds. And number of unshared electron will be A minus S. So available are 8 and shared are 6. So 8 minus 6, 2. So 2 unshared electron. So now we can draw structure here, 3 bonds and 2 unshared electron, and the whole thing has, the hydronium ion contains 1 positive charge. Okay, one more example you can see. Hydrogen cyanide, HCN. S is equal to N minus A. So available how many? 1 hydrogen, 1 carbon and 1 nitrogen. In the valence shell of hydrogen, there is 1 electron. Carbon, there are 4 electrons. Nitrogen, 5 electrons. Altogether comes to 10 electrons in the valence shell of the 3 atoms. Needed, if hydrogen, if there are 2 electrons, it will be stable. Carbon, if there are 8, it will be stable. Nitrogen, if there are 8, is stable. So how many total? 8 plus 8, 16 plus 2, 18. If there are 18 electrons, then all the 3 atoms will be stable, but they have only 10. So they share. So S is equal to N minus A. So needed 18, available only 10. So 18 minus 10, 8. 8 electrons are shared. How many bonds? Always we divide by 2 because in one bond, 2 electrons are required. Okay, they share 2 electrons to make one single bond. So we divide by 2, 4 bonds. Number of unshared electron, A minus S. So available how many? 10 and shared are 8. So 10 minus 8, 2. So 2 unshared electron. So we can draw here HCN structure. There are 4 bonds, So we draw 3 bonds here and 1 bond here. And there are 2 unshared electron, 2 unshared electron on nitrogen. Because nitrogen now having 2 to 4, 5, 6, 7, 8. And carbon is having 2 to 4, 5, 6, 7, 8. Hydrogen having 2. So all the 3 atoms are stable. I hope you like this video. If you like, please like, subscribe and share. Thank you.